Even though these angles are not marked in this triangle, can anybody tell me how I know for sure that this angle is 45 degrees and this angle is also 45 degrees? Andrew?
It's a 90-degree angle and it should make two sides are congruent.
What if two sides are congruent? What type of triangle does that make this? It's isosceles and right. If it's isosceles, the base angles are congruent. So since I've used 90 degrees, there'd be 90 degrees left and I have to divide it equally. I know that those two are 45. In a 45, 45, 90 degree triangle, then, the length of the hypotenuse is equal to the square root of 2 times the length of a leg. So if a leg is A, the other leg is also what? A. And that means the hypotenuse is A square roots of 2. Just like the 30, 60, 90 degree triangle, you need to memorize what this one looks like. The nice thing about this one is if you know that it's a 45, 45, 90 degree triangle and you forget this relationship, you can actually do this one with Pythagorean theorem. If they only give you one side, you can find the missing one using Pythagorean theorem. This is just easier. Questions on what we're going to end up doing? The problems really then are kind of similar to what we did yesterday. It's just the numbers that we're using look a little different. Take a look at example 1. Give you a chance to copy both of them down. Just like we did yesterday, we're going to go around and we're going to make sure that we place those values in our triangle. If this one's 45, over here was also 45. So I know that the two sides that are across from the 45, those are equal to A. Notice it will write in the equation. This is the easy one. And the cross from the 90 should be A square roots of 2. Well, if A is equal to 2, then X is going to be equal to 2 square roots of 2. Example 2, I do it the same way. I'm going to mark the other 45-degree angle. That way I know which sides are my A sides. X is A. This side is also A. But across from the 90 is equal to A square roots of 2. There's my algebraic equation again. A square roots of 2 is equal to 6. We do end up with the same thing that we ended up with in the 30, 60, 90 degree triangle in the aspect that I'm dividing by a square root. And what's the rule? I can't leave that square root in the denominator. Yesterday, we multiplied by the square root of 3 over the square root of 3. Had a value of 1. What are we multiplying by today? Square root of 2 over the square root of 2. Still has a value of 1, so we're not changing a value. We're just changing appearance. I now have 6 square roots of 2 over 2, but 2 goes into 6 how many times? So I end up with 3 square roots of 2 is equal to A. So X is equal to 3 square roots of 2. Everybody okay with the first two examples? Again, I'll give you a minute to copy down example 3 and 4. Again, so I don't get confused about which side I'm going to label as A and A square root of 2, I'm going to make sure that I mark my 45-degree angles, because I know that my A's are across from that. So 7 is equal to A. This side is A, but across from the 90 is equal to A square roots of 2. This is another one that's actually easy because A is how big? 7. So X is going to be 7 square roots of 2. What shape is the quadrilateral in example 4? It is a square. All 4 sides are the same, and they would have 4 right angles. What shape is the triangle then? What type of triangle is the triangle that's here on the bottom, or even the one that's on the top? It's isosceles and right, so I know that these two angles are 45 degrees. Which means where the X is A. This side is A. In fact, all the sides I could go around and mark them as A. And where the 12 is would be equal to A square roots of 2. There's my algebraic equation. A square roots of 2 is equal to 12. I'm going to divide both sides then by the square root of 2. Can't leave a square root in the denominator. We have to rationalize it. So I'm going to multiply by the square root of 2 over the square root of 2. I now have 12 square roots of 2 over 2. But how many times will 2 go into 12? So this becomes 6 square roots of 2. Which means my X was equal to 6 square roots of 2. Questions on example 3 or 4? Okay. I have one more for you. Anytime you're reading a word problem, you should read it and find out what are they asking you to find first. Here they're asking me to find the perimeter of the square. If they're talking about a square, I probably should draw a square. If it's a square, I know that all 4 sides are the same. And it says it has a diagonal, so I'm going to draw that in, of 15 inches. Well, if it's got a diagonal in it, then I know that this is 45, that this is 45, and because it was a square, I already knew the corner was 90. Which means each one of these sides is across from a 45-degree angle. Each one of these sides is A. In terms of A, how big is the perimeter right now? It'd be 4A. Okay, if I knew what A was, I'd already know what the perimeter is, because all I'd have to do is multiply it by 4. So if this is a and this is a, across from 90 is equal to a square roots of 2. There's my algebraic equation. A square roots of 2 is equal to 15. I divide by the square root of 2. I have to rationalize my denominator. Notice this time, this doesn't go into that evenly, does it? It is okay to leave it this way. There's nothing wrong with that. In fact, because they asked me to do more with it, I am going to leave it this way. If they didn't ask me to do more with it, I could take 2 and divide it into 15, which would be 7.5 square roots of 2. But since I had to do more with it, my perimeter is equal to 4 times 15 square roots of 2 over 2. And I think it's just easier to work with it this way, because how many times will 2 go into 4? So I could cross cancel this and make this 2. And what is 2 times 15? So my perimeter is 30 square roots of 2. And it would be in inches. Questions? And you should have more than enough time then to finish what? The worksheet.